school. This year class 10 mathematics NCERT or CBSE board, and this is your new chapter, that is pair of linear equations in two variables of chapter 3. This is chapter 3, pair of linear equations in two variables. So before starting this chapter, we are going to have a tiny introduction in this chapter. So that is, what is a linear equation? Pair of linear equation means, pair means two, right? Pair of linear equations in two variables. We are going to take two variables. I think children, you all know about what is a variable, what is a constant, what is a term, and what is an algebraic expression. I hope if you don't know, you can go back to the mathematics basics and then watch the basic video and come back to the pair of linear equations in two variables. Let's start here. Linear equation. An equation is said to be a linear equation if it contains only one variable with highest power 1. Let me take here, what is the general form of this? The general form of linear equation. The general form of linear equation is what? It should be having only one variable, that is x. Look here, and there is a condition a not equal to 0. What is the general form? Ax plus b equal to 0. A linear equation. What is a linear equation? It is an equation having its highest power of the variable will be 1. Okay. So look here children. This is variable. And this is constant. And this is the coefficient of this variable. So what is the general form finally? Linear equation ax plus b of, this is what? One variable, that is x. And what is its power children? Nothing there. Nothing there means it will be 1. X power 1. So what is a linear equation? An equation is said to be a linear equation if it contains only one variable and its highest power is 1. So let's take one more example here. Let's take here 2x minus 5 equal to 0 or 5x minus 8 equal to 0 or plus 8. So look here, I have given you two equations here. First equation, what is this type of equation? It is a linear equation. Why it is linear? Linear equation in one variable, having only one variable, and this variable power is 1. Right? So look over second example, 5x plus 8 equal to 0. And this equation is also having only one variable and its power is 1. So this type of equation is called as a linear equations. Suppose if your power is like this children. What happened here? 2x square minus 5. This is an equation of having one variable and its power, highest power is called degree. Do you know this? Highest power of an equation is called as a degree of the equation. What is a degree? 2. If you have a highest power 2, then it does not come under linear equation. Then what type of equation is this? It is a quadratic equation. Suppose your highest power is 3. Suppose your highest power is 3, then it will be a cubic equations. Okay, so we are going to study only linear equation in this chapter, but you should know a minimum idea. If that variable is having different power, then what type of an equation it is? right? So now linear equation and its general form is ax plus b equal to 0. Okay, where a is a coefficient, x is a variable and b is a constant. And a should never be 0. A is not equal to 0. Why a not equal to 0? If a is 0, what happens? See here, 0 into x, 0 plus b equal to 0. Then only b equal to 0. It is just a term. It's not any equation. Followed? Is this clear? Then if this becomes 0, then it cannot be called as a linear equation. Linear equation means it should contain a variable, one variable, and its power should be 1. So now, pair of linear equations. Okay, let me take these two are the pair without two children. This one. Okay. Pair of linear equations in one variable means I can say this is example. Pair 2. Pair of linear equations in one variable is this. But is that the name of a chapter? No. What is the name of a chapter? Pair of linear equations in two variable. And one more word I want to say, children. Always a linear equation. If you plot this equation in a graph, you are going to get a straight line. So look here. Suppose the same linear equation, if you are going to plot in a graph, you are going to get a straight line. And it has many solutions. See, every point on this line is a solution of this equation. Every point on the line is called as a solution of a linear equation. So now we have seen a linear equation with one variable. The same statement I am going to change for a linear equation of two variables. How can I change? Look here. A linear equation, an equation is said to be linear equation if it contains only one variable. This statement I am changing here. Look here, children. If it contains only, don't want, if it contains two variables with highest power 1, that's all. Linear equation in one variable, that is the statement. Linear equation in two variables, include this line, that is your statement. So shall we read once? Equation is said to be a linear equation if it contains only one equation means one variable. So let us add there also to be a linear equation in two variable if it contains the two variables with their highest powers 1. Let's see the general form. What is the general form of linear equation? Linear equation in two variables. Linear equation in two variables. Look here. So that will be, we need two variables. What are the two variables we are going to take? Let me take x, y. X, y are the two variables. Then ax plus by plus c equal to 0. Oh children, this is a general form of a linear equation in two variables. What are the two variables? X and y are the two variables. Then what are a, b, c? A, comma b, comma c are real coefficients. Real coefficients. Okay, we may say this as a constant or b, a and b are the coefficients also we can say. Okay, now observe carefully. If the, what is the general form for linear equation in one variable, children? It will be ax plus b equal to 0 and a cannot be equal to 0. Now what is the condition? If a becomes 0, what happens? by plus c. Then it will be a linear equation of one variable. Then a can be 0? No. Now suppose if b is 0, what happens? Ax plus c becomes. Then again it becomes a linear equation in one variable. So it should not be 0. These two values should not be 0. That means I will write a condition. A and b can never be equal to 0 in a linear equation of two variables. Okay, if one variable ax plus b equal to 0, where a cannot be equal to 0. Linear equation in two variables. What are the two variables? X and y. What is the general form? Ax plus by plus c equal to 0. Okay, we are going to start now actual chapter, that is pair of linear equation in two variables. We have two variables, but pair of linear equations I want. So look here, this is only one equation means this one. Pair of linear equation in two variable means this one. But I need two linear equations. So how can I change the same general form? I am going to change here. Look here carefully. So I will write here pair of linear equations in two variables. General form I am going to write. Okay, so same I am going to write here. How I am going to write? I don't use a two times. So instead of a, I may write a number for it. That is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. These are the pair of linear equations where a1, a2, b1, b2 are all cannot be equal to 0. a1, a2, b1, b2 are all cannot be equal to 0. Then only it becomes a pair of two linear equations. So let's mark this as a 1 and this is as a 2. So now observe these two equations here, children. By taking these two equations, I am going to show you a small tiny table which explains you full chapter. So these two are the two pair of linear equations in two variables. These two are the linear equations. That means they are the pair of linear equations in two variables. So these equations we may call them as a simultaneous linear equations. What do we call, children? They are also known as simultaneous linear equations or a pair of linear equations in two variables where a1 and b1, a2 and b2 are not equal to 0. Okay, a1, b1, c1, a2, b2, c2 are all the real coefficients. A pair of values of x and y satisfying each of the equations is called solution of the system. So these two are the general form of the pair of linear equations. So how to solve that? How can we get the solution of these two equations? There are two methods. What are the two methods? Method 1, graphical method, and another is algebraic method. What are the methods to solve these pair of linear equations? Graphical method and also algebraic method. Graphical method, in graph we plot. We use graph to find the answers. Answers of what? Two variables, x value, y value. Right? So another method is algebraic method. In algebraic method, we will be having three more sub-methods. What are those? Substitution method, elimination method, cross multiplication method. There are three methods to find the x and y value or the two variables value in a pair of linear equations. So coming to your substitution method. So what you do here, substitution method, either you bring all the equation into x form. That x form what you got, that equation substitute in another equation, get the value of y, then again substitute in x, you are going to get the x and y value. That is one method. Elimination, cancellation method, do you remember? X plus y is equal to 3, x minus y equal to 2. So minus y plus y cancel, 2x is equal to, we used to do, no? That method is nothing but that is your elimination method. Coming to your cross multiplication, this is a little new method for you. So in this chapter, we are going to learn all these. Why do we do these all, children? In order to find the x and y variable, right? So how it will be? Without doing anything, I can interpret the answer. How can I interpret the answer? By a small tiny table. Look here. a1x b1y plus c1 equal to 0. a2x plus b2y plus c2 equal to 0. This is a general form. All the pair of linear equations will be in this format only. How you compare? By seeing the equations, you will be able to say the answer. Are you ready? So listen this carefully. Then I am going to ask you 3 questions. By seeing with the eyes, you will be able to say the answer. Ready? So now, this column is algebraic condition. What is the condition, children? So look here, coefficients I'll take a1, a2. Ratio of these coefficients I will take. If a1 by a2 is not equal to b1 by b2, a1, a2, b1, b2. If the ratio a1 by a2 is not equal to b1 by b2, then what will be a graphical interpretation? How will be in graph, children? Without doing graph, we'll be able to say the answer. How? So linear equation means it will be a straight line, right? 2 linear equation means 2 straight lines. So look here. How are the lines here? The 2 lines will be intersecting. Lines are intersecting at a point. What is that, children? How do we get the graphical interpretation? If the ratios are not equal, a1 by a2 is not equal to b1 by b2, then the 2 lines are intersecting. So you are going to write here intersecting lines, okay, intersecting at one point. And then next, algebraic interpretation. What is algebraic interpretation, children? Here it will be having a unique solution. Its answer is unique. Why unique? It will be having one common point. Means the solution of these 2 equations is unique. And next, coming to consistency. Yes, it is having a solution. Therefore, it is consistent. Is the 2 equations consistent? Yes, they are consistent. Coming to your next one. This is your case 1, case 2, case 3. 3 cases I am going to say here. Suppose next one. If all the ratios are equal, that means a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Suppose these ratios are in proportion. Equal means what, children? They are in proportion. If all the ratios are in proportion, what is the graphical representation here? The lines, the 2 lines, can you see here? I have drawn a line and one more line. I am drawing on the same line. Means what? What can you interpret by seeing this? Coincident lines. Coincident lines means overlapping lines. How many solutions do they have? See here. Many solutions. See, every point on this line is a solution. Therefore, what is your algebraic interpretation here? It is having infinitely many solutions, and this have unique solution means only one solution. Infinitely many solutions. And whereas coming to consistency, is this consistent? Yes, it is having many solutions. Whereas this, I may say that it is a dependent. The solution is a dependent or consistent. Any one answer you can say, children. Consistent. Let's see the third case. What's your third case? A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. See the third case, A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. So what happens? What is the graphical interpretation? The two lines, two equations will be having two lines. Then how will be the two lines? The two lines will be parallel. So look here, therefore we get graphical interpretation, parallel lines. What you are going to get? Parallel lines. Algebraic interpretation, do it have any common solution? No, no solution at all. They are not intersecting at any point. They are not coincident. They are parallel. They never meet. Parallel lines never meet. Therefore, there is no solution. No solution. Coming to your consistency. So what happens here? There is no solution. Then what you can say? Therefore, this is inconsistent. Therefore, it is inconsistent. That's all, children. This is a little tiny basic for this chapter. Okay. So once again, have a look here. Linear equation means having its highest power or a degree 1, children. Okay, having one variable is that. Now we are talking about two variables. So what is the general form here? Ax plus by plus c equal to 0 is a general form. But we are talking about pair of linear equations in two variables. That means this is the general form. A1x plus b1y plus c1 equal to 0. A2x plus b2y plus c2 equal to 0. So we need to solve these two equations in order to guess the answer. So what are the methods to solve these pair of equations, children? There are two methods. One is graphical method and another is algebraic method. In algebraic method, again three sub-methods are there. That is substitution method, elimination method and cross multiplication method. So all four methods we will learn. Okay. So without doing anything, we can interpret the result by this table. So what is that table? I have written the coefficients here. See the three cases. A1 by A2. If A1 by A2 is not equal to B1 by B2, how will be graph? The two lines will be intersecting and the lines are intersecting and having a unique solution and they are consistent. Suppose if the three ratios are equal, that is A1 by A2 equal to B1 by B2 is equal to C1 by C2. Then the lines are coincident. That means coincident lines. How many solutions will it have? There are infinitely many solutions. Okay, and they are dependent or a consistent. Coming to your third case, A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. Then what happened? Then the two lines are parallel and there is no solution and they are inconsistent. Okay, let's see the examples now. Let's see three examples, children. You have seen our table now. So look here, children. I am going to give you a hint. Then you can pause your video and then say the answer. How to compare these with the general form of equations. See the two equations, children. First equation I'll compare with a1x plus b1y plus c1 equal to 0. Second equation compare with a2x plus b2y plus c2 equal to 0. Okay, only one problem I'll show you very clearly. So this set compare the first equation. A1 equal to 5. B1 equal to 4 or minus 4. Here in formula plus you have. So in your question minus 4. So you take here minus 4. C1 8. The next equation compare for second one. A2 is equal to 7. B2 is equal to 6. C2 is equal to minus 9. Once again, children, directly you can say A1 5, B1 minus 4, C1 8. A2 7, B2 6, C2 minus 9. Now write the ratio 5 by 7 minus 4 by 6. Just observe two ratio, you might be able to say the answer. 5 by 7 is not equal to 2 minus 2 by 3. Is it equal? No, not equal. Therefore, A1 by A2 is not equal to B1 by B2. Then what you can say? Therefore, the two pair of linear equations will be intersecting by graphical method, and by algebraic method it will be having unique solution and they are consistent. Okay, this is all you should analyze in your mind. So let's see the second one. Same manner, these two you should remember general form and then compare. That is A1 9, A2 18. See, direct I am writing 9 by 18. And next one 3 by 6. Next one 12 by 24. Until I cancel, I won't write in between. So look here, 9 2s are, 3 2s are, 12 2s are. That makes 1 by 2, 1 by 2, 1 by 2. Okay. So all the ratios are in proportion. So what you can remember? Which case you can remember? Second case. What is that? A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So what is your interpretation, children? These two lines if you do in graph, how will be your solution? It will be coincident. Means the two lines are overlapping on one another. How many solutions do it have? Infinitely many solutions and they are consistent. Okay, let's see the third example here. So 6 by 2, direct, I won't do anything. 6 by 2 how much? 3. And then minus 3 by minus 1, it will be again 3. Minus minus will be cancelled, 3. Next one 10 by 9 not equal. So which case you remember? Third case, that is what? A1 by A2. A1 by A2 equal to B1 by B2 is not equal to C1 by C2. If you want, you can see here minus 3 by minus 1 is equal to 10 by 9. If you cancel, 3 will be left. 3 equal to 3. That means A1 by A2 equal to B1 by B2 is not equal to C1 by C2. Finally, what you can say, children? By this case, I can say that the two linear equations in two variables are parallel. Yes, how can you interpret in graphical? In graphical interpretation, what you can say? The two lines will be parallel. And what will be your answer? There is no solution and they are inconsistent. Okay, like this we need to guess the answer by seeing the equations. Okay, so in our next session we are going to start your first exercise and these are all applicable in our second exercise. Okay children, with this we are going to complete our session today. In our next session we are going to start with the exercise, that is exercise 3.1. Get ready with your graph books. Okay, you should bring graph books while you are seeing my video. Thank you all.